We're going to talk about some other forms of vectors, and the first one is a unit vector, and it has a magnitude of 1. We talked about that yesterday, right? So, but then you can have a unit vector, find it, if they say something like a unit vector in the same direction. As v is given by vector v divided by the magnitude of v. I'll show you what I mean with an example. Okay, so if you have a vector for v equals the vector that is down back 1 and up 4. Okay, find the unit vector oh, you know what? This shouldn't say v. This should say u. In the same direction as, let me fix these notes, as v, okay, is given by u. U a lot of times will stand for a unit vector. Okay, not always, but so u is equal to the vector v divided by its magnitude. So for v equals negative 1, 4, find the unit vector in the same direction. That's its direction. It looks like a funny letter. As v. So all you have to do to do that is take vector v, negative 1, comma 4, and divide it by its magnitude. What's the magnitude of that? Square root of something.
Square root of...
You just do it. It's negative 1 squared, right? Plus 4 squared, which is equal to, what's that equal to?
Square root of 17.
Square root of 17. So you write this like this. The vector negative 1 over the square root of 17, comma 4 divided by the square root of 17. If you want to rationalize it, you rationalize it. If you don't want to, that's fine too. Okay? So if I took this squared plus this squared, I should get 1. Just to show you that that's true, I have the square root of that. So to find the so if I want to find the magnitude of this, I would take, so the magnitude of u, in this case, is going to be equal to, this is just to verify that its magnitude is 1, negative 1 over the square root of 17 squared, quantity squared, plus 4 over the square root of 17, quantity squared. And if I do that, I get the square root of, when I square this, I get a 1. When I square root of 17, what do I get? 17. When I square 4, what do I get? 16. And when I square root of 17, I also get 17. So 1 over 17 plus 16 over 17 is equal to the square root of 17 over 17, which is equal to 1. Okay? So what I just did is I found a vector that's in exactly the same direction as the vector that's back 1 and up 4, but it's got a magnitude of 1. If I were to draw a picture of that vector, okay, let's do that. Let's put arrows on both ends. Let's make it red. Okay, so the vector that is back 1 and up 4. So if I'm going to put some little 1, 2, 3, 4, let's pretend. So here's the original vector v. Okay, that looks like that. Here's v. And a vector that has a magnitude of 1. And so this magnitude is square root of 17, which means this length of this would be about 4 point something. So a unit vector in the same direction as that would look like it would be in the same direction, just be short, right? And its magnitude, whoops, I want it to be black or a different color. Let's make it green. So this little vector right here would be the unit vector. It's in the same direction, but it's only got a length of 1 if you were to measure it to scale. Yes? Okay, we're done with that part. Now it gets to the fun stuff.
Yeah.
So, yeah. So, sometimes vectors, oh, I skipped some stuff in the last class. Unit vector. So, so the vector 1, 0 and 0, 1 are called, or we will see in a minute, 1, 0 is equal to I. And some of you are taking physics, right? Okay. 0, 1 is equal to J. And you probably see I's and J's when you're talking about vectors in physics, right? Yes. Good. Sometimes you do I hat, J hat. So I hat means a vector in the X direction. J hat means a vector in the J direction. So these are called the standard unit vectors. Unit vectors and unit vectors. So a vector that looks like 1, 0 is just a vector that's 1 in that direction. A vector that looks like 0, 1 is just 1 up. Okay? Those are called these standard unit vectors. Okay. Now sometimes this I and J, when you see a vector v equals the x component, which we'll call v1, and the y component, which we'll call v2, we could write this in equivalent form as vi v1 in the I direction plus v2 v2 in the J direction. So all this means is that it means the same thing as this, but I just means horizontally, J just means vertically. Okay? And if you get to like an engineering class someday, they use all J's and IJ's and K's. K is like the in and out direction going. If you're talking about 3 dimensions, and then you have to multiply vectors and do all kinds of crazy things with them and stuff. So and these are the horizontal and vertical components. And I guess this has a name. It's called linear combination. Sometimes they call this standard form too. Linear combination form. Combination form. Where the other form, this I guess is called component form, which I talked about yesterday. Component form. So, so if you had the vector 3, minus 2, this means exactly the same as 3i minus 2j. It's a vector that's over 3 and up 2, which would look something like this, right? So that vector would look, if this is over 3 up 2, it would look something like that. Yes? Questions? Easy. So this makes it a little bit, this component form is a little bit easier to do operations sometimes, and especially when you get, the reason they do that, especially when you get to finding cross products and dot products, it's easier to group all the i's together and the j's together, or else you could lose track of which component is which. That's why they label them as i's and j's, because i's means the horizontal component and j's mean the vertical component. Yes, ma'am?
Why is it not down to?
Because I'm stupid. Why isn't it down to? Because I made a mistake. I'm thinking
Oh,
ahead.
okay.
They say that really smart people, they think ahead, you know, so over 3 down 2, sorry. This would look like that. No, really, like really smart people, they make lots of not that I'm really smart, but they say that really smart people make lots of dumb mistakes because they're kind of thinking ahead of the problem. But I wasn't thinking ahead. I'm just senile. All
So
right.
I'm doing bad at math because I'm really smart.
That's right. So that's right. Zach. So U equals 2I plus J, and V equals negative 3I plus 2J, and they'll say find 2U minus V. And with this, like I said, it's just a little bit easier to keep your components organized if you're putting them with i's and j's. And so 2u would look like 2 times 2i plus j when I multiply by a scalar like that, minus negative 3i plus 2j. And then I'm going to distribute, so I get that's equal to 4i plus 2j, what? Minus minus. Plus 3i minus 2j. And then you just organize all your components together. So 4i plus 3i is how many i's? 7 i's. And 2j's minus 2j is what? 0. So it's just equal to 7i plus 0j, which is just 7i. So what does that mean graphically? Let's just show you what it means graphically. Because it's kind of, whoops, I want arrows on both ends. We should just have an arrow. What flew by there? Sorry, we don't know. A bird. All right. Did you guys ever see the birds? You have to watch the birds. Yeah, that's the scariest movie of all time. All right. So in any case, who's seen the birds? You gotta rent the birds. Oh, it's classic. Classic Hitchcock. It's the best. No, someday. No, maybe after finals. All right. So what does this mean? If I take 2 of these, okay. So if I go over 2 and up 1 twice, okay? So over 2 and up 1 twice. So here's, so let's drop red vectors. So I don't want arrows on both ends, I just want arrows on one. So here's vector u. Here's vector u again, okay? So there's 2 u's. And then I subtract from it this vector. So the opposite of going back 3 and up 2 would be doing what? Forward 3, down 2. So if I went forward 3 and down 2, it actually puts me back here, okay? And so this is 2u, and this is negative v, right? And my result is the same as just going straight over 7i. See how I did it algebraically and graphically? How your results kind of confirm or validate each other? Something I did 2 of these minus 1 of those, give you 1 of those, which is 7 in the I direction. Okay, so that would be your resultant vector. Questions about that? Okay. Yes?
How do you figure out where the V goes?
Where this V goes?
Yeah.
Because regular V, so regular V would be back 3 and up 2, right? So this would be regular V. But the negative of that just goes in the opposite direction, okay? So the negative of that would be up 3 and down 2, okay? All right. So that's what we're dealing with when we talk about linear combinations of vectors. Oh, direction angles. Sorry, I'm taking more time in this class than because
It's okay.
it's okay. Direction angles. Okay, so sometimes this is called direction angle form. A vector can be written with like this. V, the magnitude of V times the cosine. Those should be angle brackets. Times the cosine of theta in the I direction plus the sine of theta in the j direction. And theta is called the direction angle. Yes, sir.
You forgot to close your angle bracket with an
Thank
angle
you.
bracket.
Thank you. Direction angle. Okay? So, and that comes pretty much at a straight right triangle trig. And theta is called the direction angle, and theta is degrees counterclockwise from the x-axis. Okay, so, and that number will always be a number less than 360 and greater than or equal to 0, right? Less than, so it's always going to be, so you can't have direction angles that are bigger than 360 degrees unlike the unit circle. So, for example, you might see something like this. Right in I plus j form, okay? We'll call it I plus j form. Or a component, what do they call that? Linear combination form? We'll call it linear combination. I'll call it IJ form. IJ form. Because I don't like big words. So V equals 6 cosine 30i plus 6 sine 30j. Okay? Did I do that right? Yeah. And so this is the magnitude, right, of your vector. So if I were to graph this vector, who can tell me what that vector would look like? What would that vector look like?
Like that.
What angle is it going at? It's going at an angle of 30 degrees. And how long is it? 6, right? So this vector looks like this angle is 30 degrees. And it has a length of 6, or a magnitude of 6, depending on what you're talking about. Not 80. Oh, sorry. I need a smaller eraser. So to write that in component form, I just multiply 6 cosine 30. Do you remember what cosine 30 is?
Pi over 6.
It's root of 3 over 2.
Root of 3 over 2, okay? So it's 6 root of 3 over 2 in the I direction plus 6, what's the sine of 30? 1/2, right? In the j direction, which is equal to 3 root of 3i plus what? 3j, right? So in other words, if I had another way to get to this point would to go over this way, 3 root of 3, and up this way, 3, right? This is 3 root of 3, and this is 3. Right, which can be found by finding the cosine and sine, respectively, of those sides. Okay, so that's putting something going from direction angle form to IJ form, or what's it called again? Linear combination form. I just always call it IJ form. Okay. Last couple things. So when you're doing linear when you are doing direction angle form, tangent of theta, can you see that? Is it red? To me it looks very light blue. But tangent of theta is equal to b over a. for V equals AI plus BJ. Okay, so this is the number in front of the I, and this is the number in front of the B. I mean in front of the J. And this tells you how to find the angle given something that's in IJ form or in component form. So say, for instance, you have right, so here we're going to do problem, right? V equals 3I minus 4J in direction angle form. So what I would do, first of all, is draw a picture of it, because it can help. Okay. Y-axis, x-axis. 3I minus 4j. Where's that vector going to be? Which quadrant is it going to be in? In the fourth quadrant, down here, right? Over 3, down 4. So somewhere down there, right? So to find the angle, theta, you know that the tangent of theta equals b over a. So in this case, it's going to be negative 4 over 3. How do I find what theta is? Inverse tangent, but you have to be really careful, okay? That's why I drew a picture of it. Inverse tangent of negative 4 over 3 is equal to, if you do that on your calculator, you get negative 53.1 degrees or thereabouts, okay? Negative. So that means that this angle here is negative 53.1 degrees. But I'm not allowed to call that, because the direction angle is always an angle between 0 and 360. So what do I call that angle instead? So theta is equal to 360 minus 53.1 degrees, which is equal to 206. I knew that. Don't tell me. Don't tell me. 306.9 degrees. Okay? Grade my geometry. 306.9.
It's easier. Why would we?
I know. Why would you object? 306.9 degrees. So that's theta, but I'm not done yet. So V is equal to the magnitude. What's the magnitude? What's the magnitude? 3 squared plus negative 4 squared, square root of that, right? Is it 5? Oh, it is. 3, 4, 5. So that's equal to 5. So the magnitude of V is equal to magnitude of V is equal to 5. Okay? So the vector is going to look like V equals the magnitude up front times the cosine of theta. What's theta? 306.9 in the I direction. Oh, I'm running out of room. Let's write it down. So V equals 5 cosine of 306.9 in the I direction plus the sine of 306.9 in the J direction. Do you get that? Okay? Because, hold on.
Why don't you just can you just take the triangle that it makes and just take the cosine and sine, 4 over 3, and like 5 over 8.
Yeah,
Why can't you not just write it like that instead of having the long,
because that's how they want it.
that's how they want it?
Yeah. Yes.
Why
Em.
is it plus sign and not minus sign?
Why is it plus sign and minus sign? What's the sign of 306? Is it a negative number or a positive number?
Negative.
It's a negative number, right? 306 is down here, so that takes care of the negative, you see? But, yeah, it's always plus, right? Because given how you define the direction angle, right, it's going to take care of that plus and minus. Okay? So you don't have to worry about it. It's just always plus. Yeah? Okay? So that's all I have for you today. So your homework is... Can I simplify that?
Do you need to simplify?
No, you just leave it just like that. You can multiply it through 5 cosine,
Yeah.
but yeah, just leave it like
Oh.
that. So your homework is gonna be index, pre-calc, where are we? Down, scrolling down, pre-calc assignments. Chapter 6, additional topics in trigonometry. Oh, place capture, new page. I'm going to change this, but, so these ones, is that right? 429? Yeah, 49 through 89. I did not tell you how to do 97, 98, and 100. I'm going to change 100 anyway to 105. But if you can look at the examples in the book and figure out how to do it, that's fine. But you don't have to do it. And this homework isn't going to be due until Friday. And I'm going to try, you can start on it now, but I'm going to try to fit in at the end of your quiz how to do these 3 types of word problems at the end of the period, okay? Like I said, if I don't get to it, I'll post it on my website. You could watch it and I'll tell you a funny joke on my website.
All right.
Okay? Do you know what this is?
That's a J.
Is it a jogger?
Jaywalker.
It's a jaywalker. Okay.
It's almost
Nice.
What?
It's a wuzzle.
A whistle.
It's a word.
Oh, that's a word. There you go.
Yeah.
I've never heard of wuzzles until just now.